YouTube channel. Today we'll be learning on the structure and the function of the cell membrane. Now, a lot of people get it confused. What in particular is cell membrane? Some people think cell membrane is the membrane limiting the entire cell. That's not entirely wrong, because if you ask someone what's the cell membrane, they mention the nucleus and the cytoplasm and what covers the cell in membrane. So that's not wrong. But the truth is that aside from the membrane covering the entire cell, some organelles of the cell are also limited by membranes. Now, but almost all cell organelles except ribosomes and cytoskeleton are limited by membranes. So that means in different places they have different names. For example, the membrane of the nucleus is called nuclear membrane. The membrane of maybe the endoplasmic reticulum can be called membrane of endoplasmic reticulum. That of ribosome, that of mitochondrial membrane. So the one of the entire cell is called plasma membrane. So when we say we want to learn the structure and function of the cell membrane, I want it to not restrict your mind to just the plasma membrane, that's plasma lemma, but also to think of every other membrane we have. So we dive right in. Now, what does the cell membrane has, and what does the structure look like, and how does it convey its function? Now, ideally, the overall main function of the cell membrane is that it limits, it says like a barrier, selecting what can enter a cell or what can leave a cell, or selecting what can enter a particular compartment and what can leave that compartment. So what conveys this? Now, generally, the cell is made up of three primary components. We have the cell membrane made of three primary components. We have proteins, we have lipids, and then we have carbohydrates. Now, the protein is the most abundant. Yeah, I feel that's strange, but then it's right. The protein is the most abundant, having about 55%. The lipids, on the other hand, are the second, 42%. And then the carbohydrates are the fewest, just 3%. So protein is the most abundant, 55, lipids, 42, and then our carbohydrates, just a small fraction, 3%. Now, what else should we know? I'll start with the lipids. Because these are the main guys. The lipids are the ones that actually convey that function we mentioned, the function of barrier. So that because they are lipids, I have lipids. Anything that is not lipid soluble will not pass freely. Oh, if you are lipid soluble, you pass. If you are not, you cannot pass. So that conveys some selectivity. So yeah, that's why it's important we know this. So let's continue. Let's dive right in. Now, which kind of lipids do I have? What kind of lipids do I have in the cell membrane? Primarily, we have the phospholipids, which is, of course, the most abundant. Please take note of that. Constituting 25% of the entire, that's out of this 42, 25 is phospholipids. Now, I also have cholesterol. Cholesterol constitutes about 13%. That's cholesterol, about 13%. Then the last percentage, these are other lipids, of which I can think of glycolipids and sphingolipids. Now, this constitutes the remaining 4%. So what are we looking at right now? The lipids. The primary lipids we have in the cell membrane, phospholipids, 25%, which is the most abundant. I also have my cholesterol, just 13%. Other lipids constitute about 4%. We have glycolipids. Then sphingolipids mainly found in CNS. Okay, so let's go deeper in. What does phospholipid do? Now, when we look at the general structure of a cell membrane, the first way people think of cell membrane, what comes to our mind is a bilipid layer. So you have the cell membrane look like this. And what we're looking at is how the cell membrane looks like. A layer on top, a layer below. So that's why we call it bilipid layer, a bilipid layer. But it's important to know that the main thing that constitutes this bilipid layer are the phospholipids. They are the phospholipids. And the structure is this way. Now, ideally, a phospholipid has two long fatty acid chains and it has a phosphate head. So the head is the phosphate head. Of course, it's a glycerol base. It tends to look like a glycerol, just that it has one phosphate now in chemistry. But then let's leave chemistry and deal on what concerns us. When you look at the phospholipid, these tails here, the fatty acid chains, are actually long And because they are tails, they are fatty acids, they are lipophilic. They love lipids, that means they hate water. So please take note that they have hydrophobic tails. That means tails that hate water, that are the fatty acid chains. But then they have hydrophilic head. The hydrophilic head is the part that loves our water. So that's just that about these guys. Now, because of the fact that almost every single part of the body has water, you now realize that the tails are attracted to themselves. It's called like hydrophobic interaction. You know, I hate water, you hate water. So both of us come together. So that's why we have them here in the middle. What they hate are on the exterior. I believe we get it. So the middle here is the middle of the membrane. Exterior in this case is the exterior of the membrane. So phospholipid is the main guy that converts selectivity. Now, cholesterol is just kinked, K-I-K-N-D, kinked around unsaturated bonds, because one of these fatty acid chains is unsaturated. That's why I have cholesterol, and its main function is fluidity. I'll talk about glycolipids later. Sphingolipids is in CNS. So that covers our lipids.